We are going to discuss on how to make your own component, and then you can put it into your schematic. That will be the topic. So let's open the KiCad and then let's see that what are the things that we can do it here. Okay, so when you open the KiCad, you have a menu here. So this is a schematic layout. So if you want to open the schematic directly, you can just click here, and then that same schematic will be open. So last time we were working on this schematic. Okay, and then if you want to go for a new symbol, so symbol means in the schematic we have a symbol here. So this is called symbol. Okay, so this is a symbol of a bridge rectifier, correct? And then we have a capacitor. We are talking about how to make your own symbol, and then we will be talking about footprint. So you have, for every component there is a footprint. So how can we make our own footprint? I will do that. Okay, so these are the things, and then these are this is a logo, and here you can make your own logo. Okay, like say you want to include your logo into the PCB. So last time we were doing a PCB design. So let me open the PCB editor. When I open the PCB editor, I don't have a logo here, correct? You see, I use some inbuilt logo. So this is an inbuilt logo which was already designed by the KiCad. Now you want to make your own logo. How to do it? So these are the three different parts which I will be segregating into three different videos, and then you can just follow this video. Guys, if you haven't subscribed my channel, please subscribe the channel, and also please like the video. It will help me a lot. So guys, let's continue without further delay. Let's go and see that the first is about the symbol editor. When you want to make a symbol editor, click on this symbol editor. Okay, then it will try to open all different types of folders which has been already created. In case if you want to create your own folder, you can create by say a new library, or if you want to use the same library, you can also use it in this same. These are all libraries actually. Someone has already done this library. If your component belongs to any of this library, or you can use the same library not to create. So you are going to create a diode. There are so many diodes are available already, but if your diode doesn't list to this diode, you can create your own diode. That's the logic, correct? So now today we will be seeing something which is not in the KiCad, and that a component we want to create it, correct? Let's search a component which is commonly available. So let's go to digital maybe isolator. Okay, so let me just go and read it. So there are so many digital isolators are available. So maybe I'll go to digital isolator, click here. Okay, digital isolators made by Texas. I want to go with Texas Instrument. Okay, in Texas Instrument there are already 67 items are already available. Okay, anyway, no problem. What you do is let's search the component, and then let's see that what kind of it's talking about. So we have one digital isolator here. Let me open this digital isolator. Isolation between your input and output. Okay, so I'm just going to take this part number, right? So you want to have a more detail, better you download dataset first, then we will come to know more detail about its footprint. You can get more about the parts details from everything from here. The how the IC will look like when I want to put it into my schematic. So okay, this is a usual layout of the IC, but I don't want to go there. I want to go to the dimension part. Yes, so I want to come here. So usually these ICs can be look something similar to this. Here this is the application schematic. So your symbol should look similar to this, and this is the application schematic we want. When I just go for this particular say part, let me just copy this part number, and let's search the same thing in this symbol editor, and let's search about this part. We don't have this part. Okay, so that means this part is not there in the KiCad. There is no symbol. I want to include this, but it is not available. So what to do? We have to create it. And then here what I will do is I will create a new symbol. Okay, so if you want to copy a similar symbol to that, you also can search a similar symbol and you can do that. Okay, and this is a device. It's a device buffer kind of thing, so it should come to buffer. Do we have any name buffer? Yes, this is a buffer. So library is already there, so I want to include it because this IC comes under the category of buffer. So let me create into buffer. When you create here, just you give the name of the symbol. When I want to give the name of the symbol, I will use the part name because this is very easy to locate when you do it, and designation will be always with U. Okay, so that reference will be start with U, and this number of unit per package, so there will be say one unit only I can have. If there is a different variant, if you have if there is a packet like say PDIP packets or TSOP packets, or so many packets are available, but in this particular design there is only one package called SMD, so that I don't want to need 2 or 3. It is only one package that I have included. And okay, fine. Now here a plain location has been created. Usually the name, I just want to put it somewhere down, and then this will be, this is the reference. So this reference you can put it, one second, I want to put it somewhere top here because I want to draw that layout here. Okay, so let's go and see this one, and then I want to make a similar layout. So this is the similar layout which I'm going to do it. So first I need to create a rectangle box. So you come here, create a graphical rectangle box. So rectangle box will be something like this, and then create a rectangle box of this size perfectly. Okay, now after creating the rectangle box as per this, there is some this pin location. So 1 to 8 on one side and 9 to 16 on another side. So first let's create this pin location. So one pin number, you just click here pin number, and when you just click the pin number, all these pin numbers are fine. First you just see that this is a BCC. So BCC is a power pin, and ground is also a power pin. So the first BCC and the ground is a power pin. So select here, is it a power input? You select this power input, and this pin name, what is the pin name you want to give? You want to give BCC. This is a name which is already given in the detail here, BCC, correct? So you take BCC, and what is the pin number? It's pin number 1. Now you take it and just put it here. So the name will say BCC and the pin number is 1. Now what will be the next one? Again, the next one is also a power input. It is a some kind of ground, but whether there is any ground, no. So it will be related to power input only. So I'll take power input, and then I will name this as a GND1. So GND1 with pin number 2. So GND1 and then pin number 2. You have this, and then you have to click it here in this 2. I have to go down to 8, so I'll just do it as usual. And this is input A. So the buffer is, this is the input A and this is the output A. So input and then output, so it is a buffer kind of thing, but there is a isolation in this IC. Okay, fine. So 1 2 3 is a int, and the last, the 6th pin is out pin. Input, normal input pin, not a power input, correct? So I will use as an input pin, and then the third is input A, INA, and it is pin number 3. Fine. Similarly again, then this also INB and pin number 4 input pin, and then this also correct, and then here again INC input C and the pin number 5. This also will be included, and the last one is out D. So it is out D and pin number 6. So this will be output pin, and here you go as this is a output pin. Pin number 7, which is nothing, and the pin number 8 is again the ground pin, ground 1. So pin number 7 is a passive pin. So what we do is just we will put pin number 7, okay, and this also name as 7, and this will be considered as a passive pin. It's not using anything, and then just put it here, pin number 7. And then the last pin number 8 is the ground 1 again, and pin number 8, and it is also a power input pin. So now I'll just put that one here. In the 9 pin, it's a ground 2, and then select is the pin here. So what we do is, again, we have a power input called as ground 2, and this is a 9th pin, and then I want to add it here in this. But here now it is needs to be rotate, so you can do rotate it, and then you can put it here, SEL, and then we have a pin number 10, add it here. So no need to repeat. Oh, again it is coming in, it needs to be rotated. Okay, let me check in the next one. And then I have pin number 11 is IN input D, and then everything will be in out. So pin number 11 will be IND, and then it is pin number 11. This is an input pin. Input D, and then I have out C. The out C pin is pin number 12. This is output pin. Okay, so this is output pin C. So this C in, C out, and next will be out B, and this will be pin number 13, and this is also out. I'll just put it here. And then next is out A, which is pin number 14, and then you just put it here, out A. And then let's see that what are the other two remaining pin. BISO is name is given here, and this is a ground 2, which is ground 1, and it is a output is ground 2. So I just want to name this one also again ground 2, the same thing. So it is also again a power pin. So fine, so I'll just put as a power pin, and then you name it here. But this power pin, usually it is a power output pin. So M, and then click, this should be here. And then I need to add one more pin called pin number 15, that is ground 2, and pin number 15, and this is a power output one. Then I add here. In this way, this symbol is completed. Okay, you can save the symbol, and then let's call this one ISO W7841. Let me just call this symbol in my schematic here. So let's call that one in the schematic. Let's see that. What is it? ISOW. It's coming here. The symbol has came here, and when you click the symbol here, this is how you get your own symbol. Are going to design the footprint of the same package which we have already done the design of symbol, and this symbol we are going to design the footprint. So to design the footprint, you have to come to the main page here, and then you click this footprint editor. Okay, you can create this footprint by your own. So now we are going to design a footprint here. The footprint is also a different kinds of library. So here we are going to use package SO is nothing but it is an SMD. It's a group of library. It is having a lot of packages here. So SOIC or anything, it is available. If you just click, you see here, and this is a SOIC here. And what kind of IC? Let's first package name of this one. This is SOIC. In the DZ key, in the description, they will have given what kind of IC is it. It's a surface mount, and it is given here SOIC, and the package size is a width of 7.5 mm SOIC. Let's go and see that is there any packages which is a 16 SOIC. So let's go and search SOIC of 16 pin. We have an SOIC of 16 pin, so we can modify this, and we may change this, because what happened is here it is 10.2 mm is given here, but what is the size? It is 7.5, so it is little smaller than the 10 mm. And the one more 6 we have here, it is 9.9. 9.9 is also still large, but here it is given as 7.5 mm width. Correct. So okay, let's take this one as this one for us. I can save as this one. So you can do the save as, and then I will save it into the package SOIC, and here I want to change the name. So SO16 I will name it as it is. And what is the dimension given here? The dimension given here is 0.25. the same thing you can copy it, and I'll just put it this details. I just want to put it this detail here, and then part I want to just edit it into my terms here. Instead of this, we'll put into, and then last pitch to pitch is 1.2 mm. Whether the pitch to pitch is 1.2 mm or not, let's go and see into the dataset. In the dataset, the pitch to pitch distance will be always given here. So let's see that what is the pitch to pitch distance. Here the pitch to pitch distance is given as 1.27, perfectly okay for us, correct? So it is 1.27 pitch to pitch distance is given. We want to only find out the distance between this. So the distance between the pin to the pin here is 7.4 or anywhere between 7.6. If you maintain this one, and then the pin size, this pad size, and this pad size is very important here. So what is the pad size? We need to calculate this pad size. How you're going to calculate? The total length is given as 10.63. So now open the calculator and just do 10.63 is the overall size of the from pin to pin, then minus 7.4. I will take the minimum size of 7.4, so minus 7.4. if you do it, you get 3.23. so 3.23 is the total length of these two lead. So therefore I need to divide by 2 again, and then you will get it. The actual length is 1.6. that means 1.6 is the length of this pad size. Now what is the width of the pad size? The width of the pad size is given as anywhere between 0.3 to 0.5. so I can use 0.5 the maximum size, and I can use instead of 1.6, you can just round up to 1.7 to have some tolerance, and then you can just make this pad perfectly okay. So we are going into that, and let's go and change that part. Fine. So for me, this pitch of 1.27 mm is perfectly okay. So I will save it into this, and then I will create a new one. Now it's saying invalid because some character is available here. Instead, I'll use this one. Fine. Oh god, some more character is there instantly. I think this character is not allowed. So I just put it here. Still, what is the error? I don't know what is the error. Some character is there. Oh, here space is available. Space is not allowed here. So I just save it. Yeah, perfectly. That was the error. So now we got that error, so we corrected it. Now we are going to create our own footprint. I think we have already created. Where is that? It is here. So this is the footprint we have already created. Now, so in this footprint, now I have to do a small measurement, and the measurement you can do it here. So what is the measurement you want to do is, this is the point. From this point, if you want to measure, and if you want to keep your measurement up to here, what is the point you want to do it? Okay, so you are not able to put it in the proper measurement. So because it is grid sizes, you have to reduce the grid size to the minimum one, then it will be perfectly can be put it. So now if I want to put it from here, okay, let's take this one, and then you just click here, and then you just click up to here. Perfectly put it. Now it is 3 mm, but 3 mm is very small, correct? We need 7. How much we need? We need 7.4. I think 7.4 is what given in the dataset here. 7.4 or 7.6. Let's take the higher one, 7.6, to have it a better one, correct? So now I want to shift it. So this is already in the center coordinate. So whatever you move this one to the side and this one to the side will be the half of the distance, correct? So now in the KiCad, one thing you remember, this axis is y axis and this axis is a z axis. So I mean to say that I'll just draw here in the KiCad platform. You have to always consider that when you draw a line in the horizontally, this line will be x. Okay, so this will be, and this right hand side will be plus side, and then if I and this side will be negative x. Right, now if I draw another line in the coordinate, and then you got a quadrant now, so in this line will be considered as y, and then whatever you go up will be minus y, and whatever you go down will be plus y. So this is what the details in the coordinate in KiCad. This is what you need to understand a lot about it, correct? So let's go into this, and then let's understand that what is the distance from this 0 coordinate to this coordinate. Fine. So now before that, let's do a small calculation. Here 7.6. Now if I divide 7.6 by 2, then that will be the distance which is traveled from 0 point to this point in a plus, and 0 point to this in a minus. Then what I am going to do is that I'll just take a simple math here. 7.6 divided by 2. So the distance traveled will be 3.8. Either it is negative side or positive side. Let's go and do it here, and then just double click. When you double click this path, you will be seeing here the position, the x position and the y position. Y position is already defined, so I don't need to change the y position. Why? Because the footprint distance between the footprint is already 1.27 mm requirement, and also the drawing says that it is 1.7. So I will not change the y, because y is the vertical one is y. I want to change only the x. So here instead of 2.5, I want to point how much I need to put it. In my calculation it came 3.8, so I just want to put here 3.8. that's all, and then if say okay, then it will see here. But what happened is, what should be the size of that, which the last when we calculated, it's an SMD, and the size of the pad. Now the size of the pad is, I told you that 1.7, which is perfectly perfect, and then y is 0.6, but the datasheet says something. Datasheet says that it should be 0.5. So he is taking 0.6 as a larger one. So for the width, we need to take the perfectly as 0.51. Why? Because the pin to pin distances will also carry in the physical when we do the physical design, the track has to go. So in order if the width is increases, the track may be coming very close to one another. That will be become very difficult in the SMD design. So we need to have a perfect calculation. Lengthwise you can do as you like, because having a better length is always, component mounting is better. So I choose 1.75 as a dimension in spite of getting 1.6 in the calculation, and we got the 0.51, so I use 0.51 as it is, and say okay. And this is a SMD, so you need to have a copper location on the front and the front mast. So F paste and the F mast should be selected. So of the other things you can keep it as it is, and then if you want the shape to be round or rectangle, you can select here. And if you and this is SMD, so I already selected as SMD. Perfect. So this is the size has been defined, and then for this one also I don't need to change the Y, so only I will change 3.8. Let me change fast. Okay, now we completed the other side. Now I want to do it on this side also. The same way here, that this it will be in the minus, as I told you that. So minus, don't edit the minus, you just simply change only the 3.8 and you just modify only 5.1. That's all. So let me continue little faster. With this we completed the other side also. Now I need to change this the location of this one. So let me just type the part. So what you can do is double click on this, but we added around 3.8, so I will add only 3.8 to this X location. So if, and here also I'll make it 5.7, must be perfect. Okay, so now this end should have 5.7. so now this is also to 5.7, so I will add here 5.7, and this also I need to go this way. So what I will do is I will add here also 3.7, so this also will become as a 5.7. so here also I will add 5.7. okay, so height I'm not changing anything. So now this one I will go and change to this one, so I'll change it to 5.7 to the end point. Fine. So in this way, the same way, let me just shift a little bit down this one, and then here this one also I need to increase this one to 5.7, and here I want to change it to 5.7 here. With this, the footprint is ready now. So if you want to identify it with a round one, you can have one round, you can add a pad, or maybe you can add a round graphics here. So I can take one round graphics with the 6 screen, and then you can have a round here like this. One second, it's not drawing. So now I'll just aim, and then I'll just drag and put it here. This will have a mark, and this cut also will have a mark. So this mark shows that the counting of pin starts from this location. So when in your PCB, in your Gerber design, this location will tell you that which one is pin number 1. That's all. And then you save this, and you just remember this part. So let me, now what happened is, now this is the symbol here. So in this symbol, when you double click, you have an here one symbol property is available. You just click this symbol property, and in this symbol property there is a footprint. So you want to map the footprint where it was. So what is the footprint what we have? SO, packet HO is here. So now I want to search for that name which we have created, that is I think SO16, correct? SO16 in the, yes, 0.295, 7.5 and P, this one, and this is what we are going to use it here, correct? And this is the footprint I have here right now, and with this I am going to assign it, correct? So double click, and then it will automatically assign the package. Now you want to map the dataset online, you can always, you can go to the this is a TI site which have the dataset in the TI. You can just copy this link and just paste it, so that whenever you generate the BOM, this link will always come. And what is the description? You want to put any description about the product, you have the description here, so you can just copy this description from here, or maybe click this one, you can automatically copy that, and then you can put it into this description, paste it. So the whole description given in the, now actually the keyword, if you want to search this item, how do you want to search? It is a digital isolator. So I want to use this keyword called digital isolator, and then I am able to search it. With this you can say OK, and then it is already assigned. And now if I go here, the footprint should be automatically came in the design here. So now let's go and do into a schematic. Instead of here, this one, if I say double click, there won't be any footprint because it is before that only I selected. So let me delete this. One second, let me delete this, and then you can go one more time and select that component. Once again you select this component, and this time when you click on this component, you will be having the everything data here. So okay, now if I go this data and put it into the PCB design, now you will be able to see that here. So I will not be able to see right now. So what I'll do is I have to first assign the annotation as usual, and then I go for net and generate the net list, because that is required to load into the PCB design. And when you come to the PCB design, just update the schematic, and then you will have a footprint. See here, you got the footprint now. So this is the footprint. Whenever you do the schematic, all these things, then you will get. So I told you that your round mark will be visible here, and all those things can be easily marked here. So U2 is the mark which is scam by default. And in the KiCad, so I'm going to include this particular part number. Okay, so this part number is what I'm going to use in my circuit right now. But what happens is, if I want to include it into the component layout, and if I try to filter this component, so I do not get this component in the KiCad. So this means that I need to design the KiCad. I need to include this particular component in the KiCad library for my design purpose, correct? So what I have to do is I need to go to the main, and then first I need to create a symbol for that. So what happens is try to understand what is the component I'm going to do this component is more look like a diode, an SMB diode. So I can simply put a SMB package, or maybe I can just go and find out a correct package according to this particular part number. So someone might have already done it in a snap PDA. So if I go to snap PDA, I found this product, this particular component with this footprint, and as well as the 3D model of this footprint. So this is already available, so I can make use of this component and put it into KiCad. But unfortunately there is no symbol available for this particular component. So what I'm going to do is that I will take a similar component. So this component look like a diode. So what I'm going to do is that I will consider a diode symbol. Okay, the CCR symbol is a diode symbol. So what I'm going to do is that I'll just click for a normal diode, and this is the diode which is pin number 1, and pin number 2 is already assigned here. And let's see that go to the database, and once more time we want to see which one is pin 1. So pin 1 is uh, this pin 1 is kind of what is it, I think pin 1 is cathode, and the pin 2 is anode. So let's verify whether pin 1 is cathode or pin 2. Here pin 1 is pin number 2 is anode. So pin number 2 is anode. So pin number 1 is cathode and pin number 2 is anode. So this remains same. So we don't need to change anything. Here also mentioned as pin number 1 is cathode and pin number 2 as a anode. So according to database, I have already verified the pin layout, and therefore I can use this symbol right now. So let me save as this symbol. What I'm going to do is I will save as this symbol, a new I will save as a new symbol inside the this is a device. So I will come to device library. Okay, let me select device is here, and in this, instead of diode, I will put that part number, and in order to identify that this is a CCR unit, so I will put a CC, let me put in capital CCR underscore and the part number. So in this device I just save this symbol. Now it comes this symbol here in a device. The only thing is that I need to assign a footprint for that, and as well as the 3D for that. So what for that I have to do is I will go to the snap EDA, and I'll download this file, okay, into the in my system, and then I will tell you how we can continue further. So let me just hang on for a time. Okay, so now the download is showing, so I will just download into this folder for my understanding. Okay, I'll go to the same folder where it was downloaded. Let me unzip it. Okay, and let's see what is inside this. We have a footprint and we have a step file. So this step file has to be kept inside the KiCad installation folder, in the save folder, you know very well. Earlier I have already shown you how to do that. So in the module, I will come to the module, and in the module you will be seeing one 3D package, and in the 3D package we have a device folder, and this device is nothing but it is some kind of SO package. So it is an SMD package, correct? So what I'm going to do is that I will go to SO series. SO series, and in this SO series I will just dump it this 3D. Okay, so this is the 3D. DIOM is the number which you have to remember, that we are going to do that work on that. Fine, so let's go here, and then what I'm going to do is that I'll come to the main menu again and create a new footprint. Okay, the new footprint will be say I need to import that footprint which was given here. So import a KiCad file. Let me go to the same model where I save my uh, project. In my project folder I saved that my new development. In this here in the sheet I have this particular footprint. So this footprint I'm just importing. I got that cathode and anode, and then let me save this. Fine, so when I'm going to save this, where I'm going to save, I will save this one in the CCR device. So let me just put it into device, but now device will not be visible. It is similar to some kind of module. So what I will do is that I'll put it into the module footprint. Okay, now in the module footprint, and then I want to map the 3D. So right now you want to map the 3D settings. You go here to the 3D settings, and then open the 3D settings. In the 3D settings, you know that I have put it in SMD SO package folder. So let me go to the SMD SO package, open this, and DIOM is available here. Import it. It is in little bit, you need to do the rotation. So this rotation needs, let me check. Okay, this is not the one. Okay, this is the one to be rotated, 90-degree rotation. Let me check the right side, it's down inside, so we need to rise up. So this is not the one. Okay, this is not the one. Okay, this is the one. Okay, so I need to rise it little bit more. So now this is mounting perfectly on the board what we seen here. So we can save it, save once again, and after that I want to map this particular footprint into that symbol which we have designed here. So this, in this you type the footprint, and then you just come to that which footprint we have saved it. We have saved it in the module. So I need to go to module M. Here in the module you will be seeing a folder here, this one. This is the footprint, I just mapped it. Now you want to link a lot of things here like data sheet, and then this description. So for this one, let us type this particular in the DZKey website. So you may be knowing about the DZKey website. So DZKey is an online component, everything is available here. So you just type it, this particular in this here in the search, you get that component, open this component link. Okay, and after getting this component, you have all the details of this component. So you want this description, copy this description. Okay, so what you have to do is you come here and then put it into the description. And what is this keyword is, this is CC I mean to say in CCR 50 milliamps. This is a 50 milliamps device, so I'll just put 50 milliamps, CC 50 milliamps, but I need to put the data sheet also. So for that you can just click here and see the data sheet is all over here. You just copy the link from here and put it into this data sheet here, so you will get a reference to that. So okay, fine, your component is ready to use it. Okay, save this. Okay, save it, and then you come to your schematic right now. So I want to insert that particular component here right now. So now I just type CCR, automatically it will come. So this is how it happened. So this is a component, you just bring this component and then you can just put it here. Let me just, okay, so just let me just fine tune it. Okay, okay, so W and sort it. So in this way I can include all this component for all my section, and this is how you can make your own component with the 3D. Today we are going to complete the symbol and the footprint and the 3D design of the components in KiCad. This is the last video, and in this video we are going to conclude everything, and then at the end I will give you a bonus information, and this bonus information will help you a lot and you don't need to do anything. So from the video 1, video 2, we were doing a lot of mathematical calculation, working and checking out the footprint size, the symbol size. We are all checking out all those things, correct? But in the last video I will tell you a secret how you can avoid doing all these things and just use it the symbol, and that logic will be given to you at the end of the video. Please watch this video till the end and you will get it. And guys, if you haven't subscribed my channel yet, please subscribe the channel and please like this video also, and let's go into that. Okay, so now as usual, so do you have looking the outlook of this product which we are already talking about. So this product looks, this is 3D. Now what we'll do is we will look out for a similar kind of 3D designs which you have already done a lot of 3D design. So if you know how to use the 3D design platform like say KiCad, okay, so you can download those KiCad available here. So you just type KiCad and you can download KiCad and install the KiCad, and then you can use the design in this KiCad platform. So you can just go to the KiCad, download the KiCad available for Windows, Mac, Linux. So if you are using Windows, just download which one is 32-bit or 64-bit, and then you can start using it. Otherwise, if you want to use this, if you want to find out if someone has already done this design and someone has already uploaded into the market, then you can also have a free design on this. So what I will do is that I'll just go to the Google site once again, and then I have a part number. Sorry, this is the description. So let me go to the part number. What is the part number? Part number is somewhere, it is given here. Yeah, this is the part number. So when I click this part number, and in the here you just type part number and then type here as KiCad model. Okay, and then you will be having a lot of model, people will be giving a lot of model in that. And here is one more, is set here. I want to search this KiCad model, and then you should be going to some KiCad or something like that. No, GrabCAD. I just want to go to GrabCAD, so let me search GrabCAD. Okay, now what is a GrabCAD? GrabCAD is a website where it's all about the 3D CAD libraries community. Here a lot of people upload their own design and then they want to sell it, or maybe someone may be giving you a free. So you can join this community, and also if you start designing your own and then you want to use it, you can share your expertise in this website, and also you can earn money from this website. So let's do that and just search the KiCad library. So let me browse the KiCad library, and in this KiCad library you can search here by typing the part number, and when you search it, nothing is visible here. Skip the toe. And what you do is actually ours is a 16-pin SOIC, so I'll just type 16 pin SOIC. Okay, that's all. And when I search this, what do I get? I get a lot of 16-pin SOIC here. Let me just type, and this is that model here. So what I click here, and then I want to download this file. So I just want to download the step file, but here is no step file. There is no step file. If it is not step file, you cannot use it into that. This is again a WRL, but let's try whether this WRL is accepted or not. View in a 3D. So we have a WRL downloaded already. It is download option was there. So what I do is I'll just click copy this, and then what I do is we have a location is in D drive. So here I have my installation file called KiCad, and here in this share folder, this is my installation folder. So KiCad, if you go to the module and you have a package 3D folder name called package 3D folder. Yeah, this is a folder here. So in this folder I am going to package SO. So you go to package SO because I am designing package SO, so I will want to store here in this package SO. And then this is the find here SO AB2 SO16 WRL. Okay, and this is the images which I'm going to load there. So let me go to my, I have an option here, footprint property. If you go to footprint property, it will open a property channel here, and then in this 3D settings, if you go to 3D settings, you will have only a PCB but no module. So there you have to open this, and by default it will open the package 3D folder. In the package 3D folder, we have to go to package SO. So package SO 3D save is here, and here I store 16. This is the one which I store here. Double click this and it came here. Now this model quite seems to be bigger than my PCB, I think so. And so what I'm going to do is I just want to find out how is my where is the location. So now this is a pin 1 and this is my pin 1, so it needs to rotate anti-clockwise. So let me not this one, no, this one, this is Z, so I have to rotate in this way. Perfect. So 90-degree, perfect. And then I need to reduce the size, scale down. I need to scale down. So what I have to do is I need to scale down, and then I need to scale down, and then I need to scale down. So first I will do is that I'll see from the top, that will be better. Where is my top view? This is a top view. So in this top view, this everything I need to scale down. So what I'll do is this is okay, this is okay, right? So all are 0.4. so let me make this one also 0.4. okay, and this is also I will make it as a 0.4. Then you can bring it this one here. So now I need to shift back to here. Then if you do it, you can place it perfectly here. Good. Now your SOIC is located. Whether it is perfectly fitted, yes, perfectly fitted here. It needs to be a little bit smaller, but okay, fine. This is a 3D model only, it's not going to represent anything, so you can have the model like this. So click say okay, and then what I'm going to do is that I'm going to save it once again, and then come to my module here. In this PCB, what I'm going to do is if I just load it once again, generate the netlist, and then go to the PCB design, and then you say refresh once again, and when it will come to this module, let me see that whether the 3D viewer will show. Still now not shown. So what I am going to do is I will directly map, but what happened is right, what we missed 1 second is we missed that assignment of this one. So what I'm doing is I will delete this, and then I will reload the components once again, because we have assigned it one. And then what you do is you have to annotate, and then after annotation completed, and then you go for netlist and generate the netlist once again, and then come to the PCB design. And then if I go for view, now probably I might be able to see why it is not visible. Why is not visible? Let me discard it. Let me just see this, and I'm taking this one, whether my view is provided. Yes, it is here, it is visible, but why I'm not able to see it? Save it. Let me regenerate that again, and then come to my here. Let me load update here itself. Okay, now I got my PCB. Close it. Now I'll place somewhere here next to here, and then let me see my 3D view. Probably yes, perfectly. Now you can see the module here. So you can see that module, how your module will be according to the pad. Now this is way how you can do it. guys, I have promised you that I will tell you what is the best way to do it, everything you want to shortcut, correct? So for that, what I'm going to do is I'm going to visit a website, and in that website I will show you how we can bring those components inside our. Guys, if you haven't liked my video yet, please like my video and subscribe my channel. It will be really helpful to me. Okay, let's go once again to Google. Google is our father, search father. So now let's type what is it, snap eda is the one which you can use it for anything related to design. So any kind of parts, if you want to search, you can search here. And this snapeda.com has a lot of components which you can get a lot of with the design itself, but you need to understand that, right? So let me copy this part, and then I'll just put this part into this here. And when I say search, wow, it has a lot of it has two parts here. But actually what happened is very bad luck, this part doesn't have any module. It has only a data sheet which is showing here, but it doesn't have any other component for this one. So let me just remove this, and then if there is anything related to a normal digital isolator, it doesn't have. Is there anything? It has a lot of digital isolator, it should be, but searching here, yes, you have a lot of digital isolator. Fine, this is, you see here, and this is showing here is you have a dataset, you have a symbol, you have a footprint, and you have a 3D model. So you can just go to this link and download everything you want, and then you can import it into your design. So now let's import this particular design. So what I'll do is I'll just click on this, it will open a page, and then it will ask us to download here. Okay, so now when you click that, download the symbol and footprint. If you want alone footprint, you can download here. If you want symbol as well as footprint, you can download here. So what is the KiCad you are using? So you are using KiCad. If you are using any other software, you can also link to that. It has a lot of software module for that one. I'm using only KiCad, and my version of KiCad, okay, it's asking me for login, so let me log in my site right now. So now if you want to download this, you can download from here. Click once again the download symbol and footprint, click here, and then you go to the KiCad. Here you we are using version 4 and later, so just click version 4 and later. It will start downloading. Wait, yes, so now I will put it into this folder. Let's go into my folder and then unzip this, and let's see that what are the files associated with this particular folder. When you open, you have a library file, you have a step file, and you have a KiCad footprint file, and this is the footprint for the KiCad model. Fine, and now I am going to import all these things, but all these things can be imported as you like, but for this step file alone, I'll just make a copy, and then what I'm going to do is that I will paste it into the same location where earlier I used to do that, correct? So KiCad module, and then I go to package 3D. Where is my package 3D? Where is it? KiCad module package 3D. Yes, here is a package 3D and a package SO 3D, and now I'll paste it here. I pasted my here it is ISO, so let me just insert ISO for here. So I'll just type here as 16. I will just type so that it will list on the top. When I open, it will come to the top, so I just put 16. So 16 pin, correct? No, so maybe make it little more, so in a pin. Okay, so it will be on top display. Let me come here, and then what I'm going Yeah, this is a footprint we are having. So now with this footprint, we were once again try to map our footprint. Maybe something may wrong. So this is the footprint, and then this is 3D. Perfect. You assign this footprint. Now the footprint is ready. Let's see that whether our this particular part is ready or not. Save it. Once again, you open the schematic. This time I'm going to delete my created component, and then I will create a new create a new component, ISO. This is the new component. I just bring that component. Wow, the layout, everything is also looks very awesome. Okay, so it just created perfectly, and with this I save it, and I want to click and just check yes, and I want to click the footprint. I want to click and see that everything is perfect. And then now what I'm going to do, I have to go for annotation as usual, and then we go for generate the netlist, and then we go for PCB design, and then when you just update your PCB, you will be able to get your new footprint here. When I put it here and then save this one and then go for view, let's see that. Wow, so you are able to see your footprint with the new this one. So this is guys how you can do the shortcut by visiting the Snap EDA website, and from here you can get all the design which you are wishing to do it. You type any component you want. Even you can buy this component from this site. I am not sponsored by Snap EDA, but I am giving you an information for your design to be very easy. Guys, thank you very much for liking my videos, subscribing my channel. Guys, today I want to talk about a KiCad. A KiCad is a software which we use for designing PCB. So I would like to open the KiCad right now. So right click on it and then run as administrator. You have to do every time with run administrator. Why? Because in case in between, if you like to modify any footprints, or if you want to modify the symbol, or you want to create a new library, you need to have an administrative power to edit the software. So in order to do that, you need to open every time in administrator login. So just right click and do it. Now in this KiCad, I already have a project here. Today I'm going to create a new project. Okay, so in my KiCad project, I'll create a new project, and I'm just trying to put it in somewhere here. So let me just create a folder name called KiCad project, and inside this KiCad project I'll just open a new folder called as a trial PCB. Fine. So in this trial PCB, you just give your project name as trial trial PCB, and I'll start a new project. Fine. So in every time you will open a layout and a schematic. Now I would like to use a schematic, and let me create a new schematic. Okay, so in this schematic we would like to create a new schematic. So to you want to know a lot of things which as we keep using, I will explain to you. And to creating a new schematic here, first you need to load the component from the library. For that you need to click here the place symbol and click on this, and then you can click anywhere on the, and then it will try to load the libraries. Now libraries is loaded. Here you can just type, I am just trying to make a rectifier, so maybe a diode rectifier or something like that. So let's do a rectifier. So for rectifier I need a bridge diode, so let me add a bridge diode. Okay, and the bridge diode is coming here. Usually most of the bridge diode will be, one will be the negative and one will be positive usually. So one will be positive and the 4 will be negative, and in between is the input. So any bridge diode will be like that. So you check this in bridge diode and then you go for okay, and then add it here. Whenever you want to supply a connection to the bridge diode, you need to have a connector. So probably I want to put one 2-pin connector. Let me put a 2-pin connector. It's a male or female, doesn't matter. Here I just put a connector here, and from this connector input you want to make a supply connection here. So let's do that one afterwards. Then after the bridge diode, so I usually we used to have a capacitor to filter the noises. So let me call a capacitor here. So capacitor should be an electrolytic capacitor. So this is a electrolytic capacitor symbol, polarized, or otherwise this is also one of the capacitor symbol which you can use. So any symbol you can call it at. This is used in US, so I just prefer to do that. And any capacitor of electrolytic should operate properly. So because of that you need to have at least one ceramic capacitor, and if that will filter your AC components properly here. So I add one more filter here, and then you need to have a regulator, voltage regulator. So you can have an L7805. So 7805 is there already, so you can call this and then it will be in the input. And the output of the 7805 you need to have a same capacitor again. You can copy this, so just place your arrow mark here and then press C, click C, then it will copy. So that copy can be called here. So a similar thing will be copy here, and then you need to have one more connector. So this connector I'll just copy here. So control C, no control, okay, C, and then it will here just R to rotate. So R to rotate, so it's rotate here. So now I use this schematic is ready for me. So let me just go and wire up. So wire, you have to come to this lid and then click W. Okay, shortcut is W, or otherwise you can click here. So if I click W, this will be highlighted. You concentrate here. I click W, see here it's highlighted. So it is anywhere in that point it will be W. So you can just click and then you can route it here in the input the similar way here. Then the same way you can route it to the other side of the input. Now you have supplied the input. Now I want to have the output will be connecting here. So you can connect your positive side here, this positive side connect here. Okay, it was missed out. And then the negative side will be connected to the negative side of the capacitor. So here you can connect to the negative side of the capacitor. If you want to mark this line as a ground reference, you can click here, ground reference, and then call for a ground. So in the power you have a ground reference. There are so many ground are there, so you use this ground reference and then click here and then call here. So this one again W to cool the wire and then click here. So it's short here and it is ground. Now this ground will be common to all the component ground. So you can just route it to your ground, and at the same time the output also will have it here. So similarly this input will connect to the input of the 7805 and the output will go to the output side, so that you will get the 5 volt output here. So any voltage here, so that will be converted into 5 volt by default here. So I want to name this connector as output. I want to name this just for understanding, and then I want to name this as input, right? So now I'm changes, and then this is a bridge diode. So this bridge diode you can use any bridge diode which is available in the market that you can capture here. So 7805 is name here. You want to use this capacitor with some say 1000 microfarad. I want to put 1000 microfarad, and it is an electrolytic capacitor. Maybe I want to use an input voltage of not greater than 50 volts, so I can select 50 volt capacitor here. At the same time this is a ceramic capacitor, so 0.1 microfarad is more than enough with 50 volt. Okay, so that will be collected here. And then this also I will put another, because it's already 1000 microfarad is already filtered, so I can have here half of the microfarad, that is 470 microfarad will be the appropriate one. So this is a 5 volt, so I don't need a very high voltage, so I can take a maximum of maybe around 16 volt capacitor will be more than enough to save the price. Okay, then the output will come here. Now the schematic is ready. Now after the schematic is ready, you need to do annotation. The first is annotation. The annotation is given here. You can go to the schematic annotation, and then you are going to assign a reference number to each and every component here. So use the entire schematic, yes, and sort component by X position. X position means, see, in the KiCad this position is Y and this position is X, so the name will be goes into the X position. So it will start from here, 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 it will go like this. This is called X position. If you want in Y position, it can go like this, Y position. If you have a lot of schematic down here, you can do Y position also. That doesn't matter. Now keep the annotation existing as it is if there is anything is there, and then if you want to reset, you can reset your annotation. Otherwise you can just click annotate and then it will annotate the keep it. Now here you have your schematic has been annotated, and you can see here the first junction will be J1, the diode D1, capacitor C1, capacitor C2. You are using on L7805 U1, and then you are using a capacitor C3 with a junction out J2, and this is called annotation of the schematic. Once you completed the schematic annotation, you can go for the you can go for the footprint assignment. So for the footprint assignment, you can come here. This is called assign PCB footprint to the schematic symbol. If you click here, it will open a separate window where you can insert your footprint which is already available in the KiCad. If you want to create a new footprint, or if you want to create a new symbol, I will show you in the next video. But in this video, I would like to complete the task by creating a Gerber file. So let me continue with the existing footprint available in the KiCad software. Okay, so we opened that schematic here, that is C1, C2, C3 all here. This capacitor, electrolytic capacitor, usually it is an electrolytic capacitor with a through hole. So we can go to capacitor through hole here, and set this kind of capacitors are all radial capacitors. So you can go directly with the radial capacitor, and 1000 microfarad is quite a big capacitor, so I can go with a little bigger size of say 18 mm dia. So for the 18 mm dia, if you want to check how it look like, you can just right click on this, and you can even see the footprint that it will look like this. So this is a usual footprint, and if you want to see the 3D of the footprint, you can also open the 3D view, and then you can see can view the 3D also here. Fine. So now we want to assign this. So what you have to do is you have to click here, and then you click on the footprint which you want to assign, double click, then it will assign here. Similarly, 0.150 is an SMD I want to use, so I will go to capacitor SMD, and I want to use a 0805 package, so you can select this one, so 0805. Similarly, for 470 and 16 volt, it will be a smaller one, so I'll go to the capacitor trace again, through hole, and then we'll go to the radial, and in the radial I will use this one, a smaller one of 10 dia. So I can go and assign this 10 dia, and then I'll come to the bridge diode. In the bridge diode, here we have a diode. So here also diode, you can go to say diode here, and then here you will be having some bridge diode, maybe around say KBL bridge diode are usually we can use for that one. So we can assign this KBL diode, and then a junction input connector 1. So connector I will go for say Wago connector, and in the Wago connector I can go for anything, or maybe what electronic connector also I have. So I will use a 2-pin connector right now. So I'll just assign this 2-pin connector, and output also 2-pin I will assign this, and L7805. So L7805 is T20 package. So that package is a true hole package. So you can go and assign from package that is a we can go to dip package. In the dip package we have TO, no TO is there. Let me search for TO, EOSOT. Yeah, I can go for TO, TO220. TO220 is the package 3-pin. So this is the package which I can use. So this package I'll assign here. So all of them is assigned. After assign, you click here, apply save schematic and continue. Click here. Once you click, and then OK, then everything will be assigned now. Now at this you can go for run. If you want to generate a BOM, you can generate a BOM from here, so that this whole component will be generated a BOM and save into a file. And right now we can also generate BOM. So when you click BOM, you just select group by value and then generate, and then it will say here success message will come. Yeah, success. So it is generated and in a file name called trial PCB. So close. We can go to the folder where our project is located. So I have in my project folder KiCad project trial PCB. Inside the trial PCB you will be seeing one, this is the file. So if you just double click and open in Internet Explorer, okay, and you can see here. So this is the item which has been generated as a and this is the combined item. So there will be two things, that if same component having 2-3 reference, so they will combine in the next column. If it is individual, it will be more or less the same. So you can go to collected component, so that common component will be created as a BOM. So this can be copied into your Excel, and then you can convert into a proper BOM file. Okay, so now what we can do is we will go to our KiCad schematic and then click on this run PCB new to the layout. So click here, it will open a layout PCB by default. So this layout, in this layout PCB, users have to we have to generate a net. So here is a generate net list. You have to click to the generate net list, create net list, and in the same folder you create its name and then save it. So when I will click once again here, and then in the net folder you click the lot net list and link to that particular net file which you have created, double click, and then you update the PCB. So it is automatically come here, closed, and then it is come here. So now we want to make a Gerber file of this one. So in order to make a Gerber file, you need to decide a PCB size. So for PCB size, you have to go for edge cut, and in the edge cut you select this graphic line, and then you draw a graphic line here. So maybe I want to just draw a rectangle box as simple as that, and then here. So this box may not be in the perfect line, there are some zigzag. In order to make this one, you can always use double click, and then you can define your own here. So if you're not able to click, you can go for 0.01, so that you can click on here. This is the start point is 151, so I will go for 151, and then Y I will go for 76, and X I will go for 200. Means from 151 to 200, if I go for say 250, X to X, so it is 50 mm in width, and then Y I will keep as it is. Understand, no? So if you go this, you will make a line now here. In this line is a 50 by 50. So I want to make this one also 50 by 50 here. You can join here this line. Okay, so you can join here, and then you double click on this, then you have a start point 276, and this also will end up to 200. The X point remain 200 straight line, and here also I want 50. So 76 plus 50, how much it will be? 76 plus 50. So I want to go x-axis of 50, so 126. So I need to assign 126 here, so 126. So then okay, it will be straight line now. So this is another 50, but this is quite big, so I can shorten it to maybe around 30 mm size. So let me just double click and check how much it's going. One second. So here it is 99, so I will go for say 100 roughly, and this I want to make it 200. Okay, that's all. Now straight line. Now this straight line also we can bring it to the location, the same one here, and then mark here. Okay, so join. See here the round is come, so it is joined. So this one also I want to make it straight line. So 200 100 is a start point, and in the that side I was starting with what is the end point here. The end, you can copy this end point here, that is end point is 276. The same thing you can put it here also, so that you can get a rectangle, proper rectangle. So here it is a 176 and 100. So y will remain the same. So okay, so 76, wow, it is that long, no need that much long, need to end somewhere here. So let me just double click and it should be 100. I will put it 100, and this one I will put it 150. Fine, then it will be perfect. Now here, this is the last line I want to join. So you can just delete this, or you can generate a line from this edge, and then to that edge you can correct. So this is the center point. You click here and then you can end it here. Okay, and if you want to check whether it is in a straight line, you can just go here, 150, 150, 70, 100, everything is in the straight line. So now this is perfectly in a straight line, and it is a rectangle board, and I want to place my component. So now here I will be using an input connector first according to my schematic. Click here and use M to move. So here, and this side is the input, so I just want to rotate this and I'll put it here. Then the next is my diode, so I want to rotate this. Okay, diode will be placed here, and then next I want to put my this one capacitor. This is a snap kind of capacitor, so no problem. And then I have this is a very big snap capacitor. Let me change this footprint. Change the footprint. If you want to change the footprint, you say change the footprint, and then the new footprint, it is not a snap-in type, so I have selected the wrong one. It should not be a snap-in type. Radial, I can go with this one, say 12.5. 12.5 is okay. Fine, change it. You can change it, close it, changes. You can change, rotate this, and then you put it here. Then the next is your this one, your 7805, rotate and put it here in 7805, and then you have a small capacitor which will be mounting here just for filter purpose. And then you have one more capacitor here, and this capacitor you want to rotate and then mount it somewhere here. Okay, I want to rearrange this so that everything can be fitted in that PCB. So I just fit it here, and this one I want to put a little bit inside here. Okay, and then I can put this connector here, so rotate it, and then this is the output connector. If you want to see the layout right now, what the layout is happening, you can just save this file and then view, go for 3D viewer, and then you can view your how your component has been placed. Perfect. Okay, even this is a wrong capacitor I have selected. I have to change that footprint. So now this also radial type, I will change the footprint, and instead of radial here, I will go for smaller radial. So 2.5 3.58 mm is okay. Change it. Okay, so now once again save it and then go for view. You can see the view. See here, it's perfectly okay. Now here the 3D is not available. For this you need to make a 3D and then you can assign it accordingly, but as of now we are not using any 3D right now. For that we don't have, so I need to go and redesign the 3D. That I will do it in the next video. Right now I want to finish my Gerber, so let me just put the track. Now I want to design only as a single board, so what I will do is I will route it on the bottom side. So this is the bottom copper. BCU means bottom copper. So now here just go for track, and then if you want to increase the track dia, you track width, you can define your here, and then you assign here. If you want to make a 1 mm 1 mm 1 mm, so you just type here 1 mm and then say add. Okay, so you have 1 mm here. So click down, select the 1 mm, and then your track width will be 1 mm. So now I will connect it, connect here, okay, and then this connect it here, and this will connect it here, and this will be connecting here, okay. But actually this is a both will be changed because I want to do a single side, but if I want to rotate this one, it will become a double side. So what you have to do is users invert, flip this component into the bottom side. So what you will do is click on this component and press F, it will flip it is changes. So you just rotate once again, and then it will be here. So many unwanted names are displaying here, you don't want, you just remove this fab, so it will be automatically will be omitted those unwanted legend. Now this will be always in the bottom side track. So now I can add with my track file again, and here I will add this track file here, and similarly this also will add here in the track file, okay. And this will go here, and this will go here, and this will go here, and this anywhere it can go in this route, so you can route it through like this. Fine, now this you have finished the routing, and also the PCB is ready for manufacturing, but you need to generate a Gerber out of it. Before that, I want to place a copper into the ground reference. So I want to fill up this full copper with a ground reference. So what you want to do is that you have to select the bottom, select the add fill zone, and just click here, and then you mark ground reference, then OK, and then you just make a layer. Total layer will be considered as a ground mark, and wherever the track is there, it will not connect. So here, so you get a layer now. So the remaining pet is filled with the ground copper, but wherever it is required eats out, it is in etching, so the copper is not fully sorted, okay. So all the ground part will be connected automatically by the adding this field. So now this is the one, and you want to add any name, you can just click here, go to the this one, the front silk layer. So in the front silk layer, if you just select, you will be able to click add text, and just add your text here. It is a rectifier PCB. I want to name this PCB, so you can put your name here. If you want to add any logo, you can just click here, add logo, and existing some logo will be available, like say CE marking logo, ESD logo, it will be available. You can just click and add those logo into your board like this, so you will be able to see that one. Just click save, and then view for the 3D viewer. Now you can see your PCB name, your logo, marking, everything will be visible. So this PCB can go for Gerber manufacturing. Before in order to generate the Gerber, what you have to do is you need to go to the plot here. When you come to the plot, first before plotting, you have to keep in mind what are the layer you want to generate. Today we are not going to generate the front copper, we are going to generate only the bottom copper. So I will remove this front, then front paste also I will remove. Front silk I want because I have a name on that. So bottom silk I don't want because bottom silk I want because one capacitor item is there on the bottom, so bottom silk is required. Front marks is not required, bottom marks is required because bottom everything is there. Edge cut I need because which I have already defined the cutting of the PCB, right? So this is the components I want, and run DRC. Run DRC means redundant cyclic, where you want to find out whether there is any unwanted connection is there or not. So close it, nothing is there, no error is there, and then you can go for output directory where you want to collect your Gerber file. So now here I will say here is a trial PCB, I will name as Gerber folder. Just click this folder, select the folder, and then you say yes, and then plot it. Now it will plot. When you plot, you want to plot the drill map also. Generate the drill file, drill map file, and close. Now your Gerber file is already generated. Now you can close this. and you can see here in the folder inside, this is the Gerber file which has been generated for production. Now if you come to the KiCad and you want to verify whether your Gerber is looking perfectly or not, you can click this Gerber viewer, load the job file. So you can open the Gerber job file, and in the job file you will be able to see your job file folder, and this is how your Gerber will look like in for the production view. So here you can those people can generate which layer he wants to print, stencil, anything. They can select the layer properly and you can keep printing whichever